Assalamualaikum and greetings everyone, especially to respective panel. Welcome to my final year project 2 presentation. I'm Sofea Anissa, BINTI MOHAMMAD PAHLEPI, a final year student in Bachelor Manufacturing Engineering Technology. The title of my FYP is Evaluation of NEEM and papaya leaf ester as an eco-friendly corrosion inhibitor for a carbon steel in 0.5 mol hydrochloric acid medium. I'm supervised by my lecturer Dr. Muhammad Fauzi bin Muhammad. This presentation will be covered by Chapter 1, Introduction, Chapter 2, Literature Review, Chapter 3, Research Methodology, Chapter 4, Result and Discussion, and lastly, Conclusion and Recommendation. Now, I will present Chapter 1, Introduction. Carbon steel is extremely strong and shock resistant. Most metals suffer a corrosion. Furthermore, corrosion can lead to loss of life and economy. Corrosion is one of the problems that carbon steel face as a result of poor protection. The corrosion is inevitable and ongoing, but controllable. By controlling a corrosion, metal has a longer lifespan. As we can see in the picture, there is a corrosion for internal of pipeline and tank. There are 3 problem statements of this study. Firstly, the corrosion process is amongst the most damaging process, producing massive economic damage in the automotive, marine, oil and gas, and aerospace sector. Furthermore, by implementing inhibitor for corrosion safety in marine and acidic environments, as well as a good protection for a metal, while the most popular application is inorganic inhibitor and the compounds are expensive, toxic and dangerous, thus can affect to human and environment. In this study, green inhibitors are used because it less expensive, biodegradable, ecological acceptable, and renewable. In the form of the circular economy, their valorization widens potential use in manufacturing field other than waste to energy. There are 3 objectives of study. Firstly, to investigate the influence of the immersion period on the inhibitor efficiency of the green inhibitor. Secondly, to evaluate the inhibitor efficiency of NEEM and papaya leaf as plant-based green inhibitor for low carbon steel in acidic medium. Lastly, to compare the performance of the selected green inhibitor in preventing corrosion in low carbon steel in acidic medium. Furthermore, there are several scopes for this study. Firstly, to study the best formulation of green inhibitor to perform as anti-corrosion performance of inhibitor on low-carbon steel substrates for apply in the oil and gas sector. Secondly, selection of suitable plants which are NEEM and papaya leaf to be estered as green organic inhibitor. And then, preparation of plant-based green organic inhibitor for extraction. Next, using EDM wire cutting machine to cut the substrate to the diameter 25 mm cylinder and thickness 4.5 mm. Next, use a hardness test and optical microscope to perform a mechanical testing on the substrates. Then, perform the corrosion test on the base metal that was inhibited by the corrosion inhibitor that was NEEM and papaya leaf. Furthermore, to study the corrosion behavior via an immersion test in 0.5 mol hydrochloric acid. Then, divide the sample into 3 groups. Each container have a 6 sample immersed within 0.5 mol HCl and with a different inhibitor for the immersion test. Then, all samples were immersed in the 0.5 mol HCl medium for 7, 14, 21, 28, and 35 days. Last but not least, using a SCM and EDX to study the corrosion behavior on the substrates after a test. Now, I will move to the literature review. In this era, steel is probably the foremost globally recognized and versatile material extracted from iron-rich ore. Carbon steel are sturdy, durable, and ductile. There are 3 categories of steel: low carbon steel, medium carbon steel, and high carbon steel. There are 3 differences, which is carbon content, characteristic, and microstructure. The advantage of low carbon steel is machinable, weldable, and inexpensive compared to other steel. They also have hardness and durability characteristics of such a composition. The application of carbon steel is automotive, oil and gas, and shipbuilding. Overview of corrosion. Based on Kadim, corrosion is defined as metal and alloy failure induced by chemical or electrochemical exposure to the environment. Additionally, wet and dry corrosion are the classification of corrosion reaction. Factor of corrosion is relative humidity, temperature, and air pollution. There are 8 forms of corrosion. Firstly, uniform corrosion, galvanic corrosion, atmospheric corrosion, pitting corrosion, crevice corrosion, erosion corrosion, intergranular corrosion, and stress corrosion cracking. Therefore, there are 5 corrosion protection methods. Firstly, protective coating, cathodic anodic protection, third, environment modification, which is inhibitor, material selection, and last but not least, proper design. Hence, the corrosion inhibitor are used, which is chemical substance that apply in small amounts to a corroding environment by reduce, delay, or prevent metal corrosion. There are 2 types of inhibitor, which is inorganic inhibitor and organic inhibitor. Inorganic inhibitor are contain toxic, expensive, environmentally harmful. But organic inhibitor eco-friendly and non-toxic, cheap and readily available, and lastly, environmentally friendly. For the plant-based green inhibitor, plant extract and organic species can be called by green inhibitor or eco-friendly inhibitor, which are environmentally acceptable and non-toxic, economic, and readily available. This is the paper finding of plant extraction, which is nearer to my research study. This is the plant that I used as inhibitor for this study. Azadiacta indica, the scientific name of NEEM, a part of Milicia family, and contains a complex of constituents such as nimbin, nibidine, nibolidine, and limonides. There are several studies that use neem leaf as inhibitor. Furthermore, papaya leaf extract as an inhibitor for my study, which is papaya leaf extract made from dry or fresh ground leaf contain a variety compound including flavonoids and other plants. There are several research studies that use papaya leaf as inhibitor. I will present about the research methodology, firstly flowchart of the progression from start to the end, and specimen preparation of corrosion inhibitor, then preparation of corrosion medium with mechanical test for substrate, after preparation extraction process, oven process, immersion test, and FTIR analysis. For after immersion test, wet loss, corrosion rate, inhibitor efficiency, surface analysis. Then after get the 3 result, analysis the result of specimen, and thesis submission. Sample preparation process according to ASTM G1. Firstly, low carbon steel, then EDM wire cut, then the sample of dimension 25 mm and 4.5 mm. Additionally, the mechanical testing of substrate, which is grinding and polishing machine, optical microscope, and Rockwell hardness testing. The machine that used for material characterization of substrate, which is scanning electron microscopies, SEM, and EDX. There are several processes of inhibitor preparation for neem leaf extract. Firstly, neem leaf was stirred and put inside the blender, then boiled, filter, extraction juice ready to insert into the oven, then insert into the oven, and neem leaf extract extraction in liquid form. Preparation for papaya leaf extract is same as neem leaf preparation. This is the fabrication process of 5 liters of 0.5 mol HCl media plus with 40 grams of neem and papaya leaf extract extraction. As a result, neem leaf inhibitor protection and papaya leaf inhibitor protection. Furthermore, corrosion testing is to determine corrosion materials resistant to environmental conditions such as temperature, humidity, and age. There are immersion tests, visual inspection as we can see in the picture. To continue the corrosion test, I calculate weight loss measurement, corrosion rate, and inhibitor efficiency. Based on graphics shown, there are 3 novelties of this study. which are green material and safe, act as a barrier coating, and lastly corrosion behavior and cost. I will explain the result and discussion. Firstly, microstructure testing is important to prove the chemical composition which are ferrite and pearlite towards the sample. Meanwhile, hardness testing described as a metal resistant to plastic deformation against indentation. For example, in the picture, the 5 points and the bar graph shows, and the average is 69.74 HRB. I will move to FTIR result. What is FTIR? Defined as a technique for obtaining an infrared spectrum of a solid, liquid or gas absorption. From the left side, we can see the difference of NEEM and PAPAYA leaf analysis, and then NEEM leaf FTIR result, then lastly PAPAYA leaf FTIR result. So as we can see on the table, there are green inhibitor performance for 3 different types of solution which are without green inhibitor, neem leaf extract and papaya leaf within 35 days. The reddish brown color on the surface obtained is defined as a corrosion product. When the immersion date increase, the corrosion product are more visible and on 35 days worse than the surface on the specimen on day 7. As we can observe from the graph of weight loss measurement, there are 3 different lines which are great performance of green inhibitor shows the lower weight loss measurement that represent neem leaf with orange color, and without performance of green inhibitor shows the higher loss due to the unprotect the metal substance in 0.5 mol HCl that represent lime blue color. In addition, this is the corrosion rate graph of specimen for 35 days after calculate the corrosion rate. As we can observe of 3 different lines, the great performance is green inhibitor and the best is neem leaf which represent orange color, and while the blue color line without green inhibitor shows the higher corrosion rate. Furthermore, we also calculate the inhibitor efficiency for 2 types of green inhibitor. As the comparison, the better efficiency is neem leaf and then followed by papaya leaf. So, this is the SEM and EDX analysis as indicated in the picture on the right side. As the observation, the weight percent of ferrum of neem leaf is the lowest compared to other mechanism, and this proves it is better performance. Now I will discuss about inhibitor mechanism. The chemical substance that used when they present in the corrosion system, inorganic compound that absorb on the metallic structure to isolate it from its surrounding, the media to stop the oxidation reduction process. And inhibitor create the inhibition by absorbing their molecules on the metal or alloy surface to perform a protective layer. And its suitable concentration can decrease the corrosion rate without change the corrosion rate of corrosive agent. As we can see the difference, the absence in inhibitor and the presence of inhibitor on the low carbon steel, inhibitor act as a barrier. Then, this is the infographic of evaluation of neem and papaya leaf extract. Firstly, neem leaf and papaya leaf, then from that, the solvent and extract, and the FTIR result for the extraction, then the immersion test for 0.5 mol HCl, papaya leaf and neem leaf. Then we do a calculation and do a graph for weight loss measurement and corrosion rate, and do the analysis for 3 different solutions which are clear specimen, papaya leaf solution and neem leaf solution. This is the proof of the surface morphology. Potential commercialization is pipeline, oil and gas equipment, metal structure, and on offshore structure. In a nutshell, as a conclusion and a recommendation, neem leaf extraction show a good potential as green corrosion inhibitor, and the amount of rust of the carbon steel coupon reduced towards the weight loss decrease. Then, this study of the corrosion inhibitor on the low carbon steel perhaps used in oil and gas industry, since it's suitable in a closed system. This is the Gantt chart activity for PSM1 within 16 weeks. Moreover, this is the Gantt chart activity for PSM2 such as meeting and discussion and cut the material. Hence, following this study, there are a few references for this study. Thank you very much for giving me this big opportunity and have a nice day.